Writing equations of parallel and perpendicular lines through a given point. In the past, we've talked about parallel lines, and we know that they have the same slope and different y-intercepts, which makes sense because the lines will never cross. Perpendicular lines have slopes that have opposite signs, so one is positive and one is negative, and they're reciprocal of each other. They can have the same or different y-intercepts. In the past, we've been asked to write a parallel line or perpendicular line to a given line, but have not specified any point to go through. Now, we will have to do that extra step. Now let's look at an example. Fill this in your notes, and if you have a different version of the notes, then write this on separate paper. Write an equation of the line that passes through -8, 2 and is parallel to y equals 3/8 x plus 1. If I want a line parallel to this line, the only thing I care about is the slope. I know that there's going to be an infinite number of lines that are parallel to this line. It's all the lines that have a slope of 3/8. But now, this particular line that I want also goes through the point -8, 2. There's only one line that's parallel to my original line that goes through that point, so I need to find the y-intercept. I'll start by writing that the slope of my line is 3/8. Or m equals 3/8. Then I want to write my new slope. My new slope, since it's a parallel line, is also going to be 3/8. And I know a point on that line, -8, 2. If I didn't have this nice setup at the top, my paper would look like this. M equals 3/8. I got that because that's the coefficient of x when y is isolated in my equation. Then I'd write that my parallel slope is also 3/8, and that I'm going through the point -8, 2. At this point, I no longer care about my original line. In fact, if you wanted to, you could forget about your original line, because the only thing we care about is a slope and a point. So I'll plug this into yx equals mx plus b, just like we've done in the past, and I'll find my y-intercept. I substituted in my x, my y, and my m, and when I multiplied my slope with my x-coordinate, I got -3, so I added 3 to both sides, and I found my y-intercept of 5. That means that my equation is y equals 3/8 x plus 5. Now visually, we could check this on the graph, and we could take our point, and we could go up 3/8, and we'd see that this is in fact the correct y-intercept. We also could substitute in our point -8, 2, which is how we should always check this kind of equation. And we're done. Example 2. Write an equation of the line that passes through -4, 4 and is perpendicular to y equals 2x minus 5. So the first thing I need to do is identify my slope. The coefficient of x when y is isolated is my slope. So my slope is 2. Then I figure out, well, what's the slope of my new line? My perpendicular line, or my new slope, is going to be the reciprocal of this with the opposite sign. So I have my slope, and I'm given a point. And I need to find the equation that has a slope now of -1/2 and goes through the point -4, 4. So again, I'm going to plug that into y equals mx plus b. When I plugged it in, I got that my y-intercept was 2. So my equation is y equals -1/2 x plus 2. I double check that it would go through -4, 4 by substituting in -4 and 4 to make sure I get a true equation, which it does. And I double check that my slope is the opposite sign reciprocal from my original slope, which it is. If I wanted to, I could graph both of these lines and I would see that they were perpendicular. I graphed the two lines on the graph to the right to confirm that they do in fact form a right angle. Pause the video and try number 2 on the you try problems. Then press play and see if you got the same answer as me. The first thing I did was I isolated y by subtracting 4x from both sides. Then I wrote that my slope is -4, so my parallel slope is also -4, and I go through the point 10, 7. I now have a problem that I need to solve by substituting these values into y equals mx plus b. When I substitute in my slope and my point, I get y equals -4x plus 47. I'm going to check it in my head. Let's see if when I substitute 10 in for x, I get a result of 7. Negative 4 times 10 is negative 40, plus 47 is positive 7, which is my y coordinate, and therefore I've done it correctly. Thanks for watching.